save me.
It's not going to evaluate the next one.
It's not going to evaluate the next one because I'm lazy. In other words, laziness saves the day. Okay? The problem is solved because I'm lazy. Because the moment I know I is less than bar A bar is false, I don't bother to check the other part of the conjunction. And since I'm not checking the other part of the conjunction, I would not use I being 2 as an index in this case. So I would never initiate the access to the element that does not exist. And it will still make the loop exit, wouldn't it? Because if one condition is false, the entire conjunction is false. But when you look at the algorithm, when the condition is false, you still get out of the loop and go to post. Okay? So this is called short-circuited evaluation. Short-circuited evaluation simply means that as soon as you can determine the result of an operator, you don't bother to look any further. That is short-circuited evaluation. And it is a common thing in almost all modern programming languages. This is the standard of C. It is also the same in PHP, Perl, Visual Basic, and so on. Do we have any questions about the nature of short-circuited evaluation?
What's the difference between and also?
And, okay, you're talking about VB-specific operators. In VB, and the use of and by itself is short-circuiting. In other words, it behaves exactly the same way as we specify here. When you specify and also, it would actually evaluate both sides of the conjunction. You're basically forcing VB to say, look at the other side anyway. Even if the conjunction is false to begin with, go ahead and look at both sides of the conjunction. I personally don't know why you have to do something like that, or when is a situation to look at both sides of the evaluation. I think those will be fairly rare situations. But in VB, it gives you an option not to use short-circuited evaluation by the use of and also. There's also one for or, it's or else. So are there any questions about this solution? Okay, we fixed the problem just by reversing the order of the conjunction and relying on short-circuited evaluation. This is a very standard C method of solving this problem. So when you move on to cisp300 and just about any programming classes, it will rely on short-circuited evaluation when it comes to accessing arrays. Do we have any questions about this particular program? But what if there's no short-circuited evaluation? How do you fix this problem? Okay, so I'll save this file and then save it as a new name. And this time we say no short-circuiting. It forces it to evaluate the two comparisons in different statements, right? That's one way to say it, one way to do it. The other way to do it is to introduce additional variables. Okay, you can introduce additional variables to do it. So if I were to fix this without using short-circuited evaluation, then I would fix it like this. I would make a new variable called found, and I would initialize the new variable found to be false. Okay, so I would assume that the value I'm looking for is not in the array to begin with. So when I specify my loop in this case, okay, I need to change the indentation back. When I specify the loop in this case, I will have to say while I is less than bar A bar and not found. Do the following, right? Because I certainly want to perform the loop when the item is not found yet, and I'm not at the end of the array yet. What do I do inside this loop? Well, one thing I know for sure is I need to set the value for found. Now, found in this case is a Boolean variable. How do I know it is a Boolean variable as opposed to an integer variable?
Because you said false.
Yep, because I set it to false to begin with. So that means it is a Boolean variable. The way I assign a value to found is a bracket I equals k. And I'll use extra parentheses just to make it very clear of what we are doing here. In this case, line 4 is going to, what is the right-hand side of the assignment? Yep.
That will evaluate true. Without an if statement, that bound will evaluate true if a equals I equals k, it will automatically evaluate true.
Yeah, there's no problem with that.
In all programming language, wouldn't that be?
Yeah.
Okay.
Yep. Okay, well, let's take a look at this statement on line 4. What type of statement is it?
Assignment statement.
It's an assignment statement because of the left arrow. What is on the right-hand side of the assignment statement? It's a comparison, right? It's a comparison to see whether a bracket I equals to k, right? Does it return a value? Does that expression give me an answer, a result of some kind?
Yes.
What kind of a result does it give me? A Boolean value, a true-false value. Okay? What is on the left-hand side of the assignment? We have a variable, and the variable is of the type what?
Boolean.
It's a Boolean. So we have a Boolean value on the right-hand side, and we have a Boolean variable on the left-hand side. Is there a problem? Nope, there's no problem. So this means that on line 4, it would carry out the comparison. It will check whether a bracket I does equal to k or not, which will end up with one of two possible results. It's either true, yes, they are the same, or false, they are not the same. The true-false value, which is the result of the comparison, will just be stored in the variable found. In other words, it's no different from I gets I plus 1 or I gets initialized to 0. It's just that the type of the variable and also the type of the expression on the right-hand side, they are Boolean instead of integer. Are we okay so far? Because the other way to do this is to use a conditional statement, which is long, complicated, and unnecessary in this case. The next thing we have to do is to increment I to I plus 1, just like before, and then we have and while. So now my program is a little bit longer because I have to introduce the extra variable. The question is, does it still work?
It doesn't tell you which value k was found in which index value.
It only tells you whether it was found or not, but it does not tell you whether what is the index of the element that has the same value as k. You are correct. Yep. So do we have any questions about this version of the algorithm that does not rely on short-circuited evaluation? No questions? Are you guys starting to see the value of short-circuited evaluation? It makes your life a whole lot easier when you write programs. Okay? Are we okay so far? Okay. So let's go ahead and close this. And close that. So now we have an algorithm to search for a particular value. And then we can now move on to the next module. Are there any questions about arrays? No? Well, let us not move on. I will mark that this is our next topic, but instead I will just go ahead and give you a few more examples just to make sure that people understand what arrays are and what they can do. Let me give you an example. Let's say a bracket 0 is assigned a value of 5. Well, let's pick 3. A bracket 1 is assigned a value of 1. A bracket 2 is assigned a value of 0. 0, 3. So a bracket 3 is assigned a value of 2. Okay, well, one of these is not reachable. Let me see how I can fix it. 1, 3. Okay, so that's 1, 3, 2. 0. Okay, so now everything is accessible. So now I want to ask you, what is the value of this? 2, 3, 4. Well, first of all, does it make any sense? Can I do something like this? What is the restriction? What is the restriction regarding the use of the square bracket operator? It has to be an integer. And it should be an integer that is within a good range, which is from 0 up to bar a bar minus 1 in this case. Well, we know all these values are less than 4, and 4 is the bar a bar, the number of elements. So we know that this should be okay. Is it okay for me to do something like this? Absolutely. But how do we evaluate something like that? We start with what? We start with the innermost one, right? So in the innermost one is a bracket 2. What is a bracket 2?
0.
A bracket 2 was initialized to 0, so we can just do it like this. Is that okay? And you guys can see right away that we can just do it one step at a time. What is a bracket 0?
1.
Okay, this whole thing is 1. So now we have just 2 more levels to deal with. A bracket 1 is what?
3.
3. Very good. And what is a bracket 3? 2. We got back to 2. Okay. Now I'm introducing this not to confuse you guys, but to show you that there's no limitation of what you can put inside the square brackets. All it needs to be is an integer within the right range. The way you compute that value is entirely up to the application and up to the code. Yep.
What's a practical application that you would use that type of array for?
When you have a linked list implemented by an array, okay, it's not quite. We are not quite there yet. There's no value in doing it using an array of integers. But when we start to have records, then you can have one part of the record to indicate where do I find the next record of an array of records. So we will get to that point, but I just want to show you that you can do something like that. And the only restriction is it has to be an integer inside the square brackets, and the value of the integer must be from 0 up to bar a bar minus 1. Okay. Okay, so that's good. Now we move on to the next modules. The one module is short-circuit evaluation, and the next module is searching in a sorted array. We have just covered short-circuit evaluation. Okay, just moments ago we used an example to illustrate what it is and what kind of a problem does it solve. So we'll just kind of bypass that because we have already covered it, and we'll jump right into searching in a sorted array. Now, why do you think a sorted array is advantageous? Why is it a good thing?
You don't have to search every element. You can break them in half to get binary.
Okay. Well, if you just think about it, what happens when your phone book is not sorted? What happens when your dictionary is not sorted? Then you have to use the linear search algorithm, don't you? And with a linear search algorithm, when it hurts is when the word is not in the dictionary. Okay? Because in linear search, there's no way to tell or confirm the word does not exist until we have examined every single entry in the dictionary when the dictionary is not sorted. When the dictionary is sorted, it's really quick to say, oh, that is not a word, because you can actually use certain tricks to find out that the word actually does not exist, right? So the first thing we want to do is a slight optimization of the algorithm that we have seen so far. In other words, we will change our